This galaxy is already dead, and the universe was barely born. I want you to sit with that sentence for a second, because breaks the timeline of the universe sounds like it should mean something flashy, time travel, paradoxes, science fiction stuff. It's not that. It's quieter and, honestly, stranger. Astronomers found a galaxy that's massive, mature, and completely finished. Done growing, done forming stars, done spinning, showing up at a moment when the universe had barely had time to strike its first match. That's the whole mystery. Not a glitch in time, just something old showing up impossibly early. Let's go after the assumption everybody carries into this without realizing it. We think young universe automatically means young, small galaxies, messy little clumps of gas and stars, still figuring out how to exist, nothing structured yet. That's the standard picture, and it's a reasonable one. Small beginnings for a small amount of elapsed time. So finding a galaxy that's already massive, already red and dead, as astronomers bluntly put it, this early in cosmic history isn't a minor surprise sitting at the edges of the data. It's a direct contradiction of the whole framework. Now, how do astronomers even know a galaxy is old just by looking at it? This is where I want to slow down, because the mechanism here is genuinely elegant. There are two separate fossil records buried in a galaxy's behavior. First, whether it still spins in an orderly way, stars tracing neat, coordinated orbits around a center, like the hands of a clock all sweeping together. Second, whether it's still actively forming new stars, or whether that process has shut down entirely. Orderly spin plus active star formation, that's the signature of youth. Random, directionless stellar motion, combined with quiet, quenched star formation, that combination normally takes billions of years and dozens of violent mergers to produce. It's not a guess. It's a genuine clock, written into how the galaxy moves and glows. So here's the actual find, and I want to give you the real numbers because they matter. A massive galaxy, several times the mass of the Milky Way, has been confirmed to have already stopped forming stars and to show no rotation at all. It existed only about 1.8 billion years after the Big Bang, and the standard recipe for producing that kind of slow rotator, the technical term for a galaxy with that kind of random, settled stellar motion, is thought to require roughly 10 billion years and dozens of mergers. 10 billion years needed, less than 2 billion available. Do the subtraction. There isn't room in the timeline for the process that's supposed to produce this result. So what's the best explanation researchers actually have? And I want to be careful here, because there's a difference between a confirmed mechanism and a strong, well-supported guess. The leading hypothesis isn't the slow grind of dozens of mergers stacked across cosmic time. There simply wasn't time for that. It's a shortcut, and a violent one. A single head-on collision between two galaxies spinning in opposite directions, which would cancel out their rotation almost instantly, the way two spinning tops slammed together dead center just stop, rather than gradually winding down over years. And this isn't pure speculation. There's actual evidence pointing toward it. Astronomers found excess lopsided light on one side of the galaxy, consistent with leftover debris from a recent major merger that hasn't fully settled yet. That's exactly the kind of messy aftermath you'd expect from a genuine collision, not the clean, symmetric shape you'd get from a slower, gentler process. And here's the part that actually gets me, the paradox sitting right at the center of this. This isn't evolution running a little ahead of schedule. This is evolution skipping almost the entire line. A single catastrophic event compressed what should have taken roughly 10 billion years of patient accumulation into a sliver of cosmic time. A few 100 million years, maybe less. Imagine watching someone go from infancy to old age in an afternoon, and the only explanation on offer being some violent shortcut nobody had previously thought possible. That's roughly the scale of what happened here, just translated into galaxies instead of people. And this isn't some lonely anomaly sitting off by itself either. That's what makes this genuinely worth paying attention to, rather than filing away as a curiosity. This fits into a growing pattern of Webb surprises. Massive, mature-looking galaxies showing up far earlier than anyone predicted, some looking too structured, too bright, too developed for their age. Multiple explanations are competing for acceptance right now. Some researchers propose early star formation was simply more efficient than our models assume. Others point to dark matter interactions accelerating structure formation beyond what gravity alone would explain. And a smaller group is asking whether this means adjusting the standard cosmological model itself. That's not one settled answer. That's an active argument happening in real time across multiple research teams because the data keeps refusing to behave. I want to be honest with you about exactly how confident we should be here, though, because overselling a single case as proof of a new rule would be dishonest. One confirmed galaxy like this isn't a full population study. It's a strong, well-evidenced individual case, and that's exactly the language researchers use around it. Careful words like candidate and strong evidence, because even the compelling explanation isn't the same thing as absolute certainty. What this discovery does prove concretely is that our instruments can now resolve this kind of detail in galaxies from over 11 billion years ago, a capability that simply didn't exist before. We couldn't properly ask this question until recently. Now we can, and we're finding answers we didn't expect. Here's where I think this actually widens into something bigger than one strange galaxy, though. We used to imagine the infant universe as something like a nursery, calm, patient, slowly assembling itself piece by piece over billions of years. Nothing dramatic happening yet. Webb keeps quietly dismantling that image. What it's revealing instead is a rougher picture, an early universe where the biggest structures were already finished growing and already breaking the rules we'd assumed governed their formation, before the cosmos had even reached what you'd call its toddler years. Less nursery, more demolition site. Less patient construction, more accelerated collision. So I don't want to close this with something neat, because I don't think this deserves neat. A galaxy's motion, the way its stars spin, or don't, is a memory written directly into light. A fossil record you can read across billions of years if you know how to look. And this one galaxy's memory is telling us something the rest of cosmic history says shouldn't be possible yet. That age itself can be borrowed early. That maturity isn't strictly a function of time passing patiently. Sometimes, if the universe gets violent enough, at exactly the right moment, something can become old long before it should have had the chance. Somewhere out there right now, that galaxy sits motionless, silent, surrounded by countless younger galaxies still spinning around it, a corpse in a nursery, holding a memory of a crash that happened before most of the universe had even learned how to build anything at all.